So question number 1, this is from page 165. What do you notice about this system that's a little bit different than the ones we did yesterday? The third one, right? The third one, usually we're solving 3x3 systems. Right here we have 3 equations, but not all 3 equations have 3 variables. We have an A, a B, and a C. We have an A, a B, and a C. And over here we only have an A and a C. It's missing a B value. But let's go back and think, what's the goal of when solving a 3x3 system? What do you want to do? You want to convert it to what? To a 2x2, right? That's the goal, because we know how to solve 2x2s using linear combinations. So the goal is to get a 2x2, which means get 2 equations. Usually we call them new equation number 1 and new equation number 2 that only have 2 variables in there. But we already have one of these equations. It only has 2 variables. It only has A and C. So I know that this guy right here is going to be part of my new 2x2 system. I could call this new equation number 1, whatever I want. But when I create my new 2x2 system, this is going to be one of them. I mean, I don't have to do this, but this is the quickest path, right? So I do want to take the other 2 equations and modify them and get the same variable to cancel that this one's missing. So which one's this missing? B, right? So we need the B's to eliminate. So what would I have to do to the top equation to get the B to eliminate? Multiply it by 3. And the bottom equation, I'd have to do what? Multiply it by 4. Okay. So this is going to be kind of ugly. It's going to look like a football, what do you call it? Man, I can't even think right now. Sorry. Play, a football play. That's right, with arrows and stuff. So let's rewrite that top equation right here in blue. 3 times negative 3 is negative 9 with an A. 3 times negative 4b is negative 12 with the B. 3 times 2c is 6 with the C. And 3 times 28 is 60 plus 24 is 84. Everybody with me? Okay. And then let's take this other one that I'm going to multiply by 4, and I'm going to put it right down here. So again, 4 times A is 4A. I need to distribute the 4 to each term, right? 4 times 3 is 12. Positive 12 with the B. And then 4 times negative 4 is negative 16 with the C. And 4 times negative 31, it's going to be negative 124, right? Thank you. All right, so why did I modify those 2? To get the same variable B to cancel from our third equation. So the B's cancel. They eliminate. Negative 9 plus 4, that's negative 5 with an A. The 6 minus 16, that's negative 10 with the C. And it equals, what is that? Negative 44? No, negative 40. Yeah, negative 40. So ladies and gentlemen, this is our new equation, but you know what? Notice that there's a 5, a 10, and a 40. They're all divisible by what? 5. So you can do whatever you want to an equation as long as you do it to the whole equation. Bless you. So let's divide everything by negative 5. That way it'll make this new equation a lot nicer to work with. All right? So technically, this is my new equation number 1. My new equation number 1 is A plus 2C equals 8. That's technically my new equation number 1. But I purposely made this new equation to have the missing B value. Now, why is that? Because this third equation has a missing B value. So right here at this point where it's like, use the equation you haven't used. Okay, that's this one. And get the same variable to eliminate. Well, I purposely eliminated the B's because this one doesn't have a B. And your goal is to create a new 2x2 system. So just rewrite it here and take this one and put it right below. And we have A plus 2C equals 8. I apologize for the sloppiness. So that's our new 2x2 system. That's what we call step 3, the new 2x2. And we all should be able to solve 2x2 systems. So what would you like to cancel, A's or C's? A's, okay. So what am I going to multiply the bottom one by? By negative 2. So So the top equation is going to stay the same. I'm just going to rewrite it. Let me get a little more space here. And the bottom equation, after modifying it, we will get negative 2a. 2 times 2 is 4, but negative 4 with the c. And negative 2 times 8 is negative 16. And combine the lines, eliminate the a's. We have negative 1c equaling negative 5, which means our final answer is c equals positive 5. So we have one answer. Now remember, we created a new 2x2 system. So let's completely solve this 2x2 system. So we have the c value of 5. Let's take the 5 and plug it back into anyone we'd like. 5, the red one. Okay. So let's go 2a plus 3c equals 11. Let me write that over again. 2a plus 3c equals 11. And I put parentheses instead of c because we know that 5 is c, c is 5. So let's put the 5 right in there. And we have 2a plus 15 equals 11. Subtract 15 to both sides. And you will get 2a equals negative 6. No, negative 4, my bad. Which means that a equals negative 2. So let me move this a little bit. There we go. So a equals negative 2. So we have two answers. We have the a, the c, and we still need the b value. We need to go back to the original and plug in the a and the c to find the b. So which one would you like to use, the first one or the second one? We can't use the third one because there is no b. We won't be able to solve for b. Second one? Okay, so the second one, let's just rewrite it. It says a plus 3b, but instead of a, I want to put parentheses, plus 3b. We don't know b. It says minus 4c, minus 4, but we're putting parentheses instead of c, equals negative 31, equals negative 31. I hope everybody sees that I just rewrote this middle equation right here, but instead of a and c, we did parentheses because we're going to be plugging in the a value right here and the c value right here. So a is negative 2, c is 5. Let's solve this equation. Negative 2 plus 3b minus 20 equals negative 31. And getting more space here, we're going to combine like terms, the negative 2 and the negative 20. That becomes negative 22. And we still have the 3b out here in the front, equals negative 31. Final two steps would be to add 22. We'll get 3b equaling 9, negative 9, yeah. So our final step will be to divide by 3, b equals negative 3. So we do have our a value of negative 2, our b value of negative 3, and our c value of negative 5. So our ordered triple, we're going to write our answer as parentheses, alphabetical order, negative 2, negative 3, and the c value of 5. Okay, so a lot of students get confused because that third equation only has two variables. Use that to your advantage, right? This is what we want. We want two of these. We want two equations with two variables. So if they already give you one of them with two variables, just put that to the side, and that's going to be part of your new 2x2 system. And then use the other two to eliminate that same missing value so you could have the other equation, your other new equation of that 2x2 system. So it's actually an easier problem than if they wouldn't have given you this two variable equation. Make sense? And of course, if you're ever confused, I would take this negative 2, plug it into A, take the negative 3, plug it into B, take the 5, plug it in for C, do the math with the calculator, see if it really does give you 28. Okay. Then do the same for here, see if it gives you negative 31, do the same for here, see if it gives you 11. If it works for all three of them, there is no way that you could be wrong. It's absolutely correct. Okay. So we're going to check number 5 right here. This one is a 3x3 system. There is 3 variables in each of these 3 equations. So we need to first decide whether we want to cancel x's, y's, or z's. Which one do you believe is easiest? I'd go with z's. So I'm going to cancel out the first one. I'm going to make it cancel the second one. So the first one, I'll make it cancel the second one by multiplying by 5. So the first equation modified by 5 will be 15x plus 25y minus 5z equals 60. My middle equation, I'm just going to rewrite it. And of course, now that I've modified the top equation, I could combine them and the z's will eliminate, giving me a new equation that only has two variables, x's and y's. So 15 take away 2 is 13 with an x. 25 take away 3 is 22, positive 22 with a y. The equal sign comes down. 60 plus 14 is 74. Again, this is our new equation number 1. That's really step 1 right there. We're going to use that new equation number 1 later to create a 2x2 system. Anyhow, let's use the equation we have not used. We already used the top and the middle. Let's use this bottom equation. I'm just going to rewrite it right here. And then I need to get the same variable z to cancel. So I don't want this positive 3z. So I want to get rid of this positive 3z by taking the top equation and modifying it by multiplying by 3. So I could get a negative 3 right here, which will cancel with the positive 3. So maybe if you have different colored pens, I recommend using them. I want to take that equation and I'm going to multiply it by 3 as I bring it down. You don't have to do this. You could actually rewrite it exactly the way it is and then modify it. But to save some space, I want to take this equation and as I bring it down, I want to multiply it by 3, giving me a new equation that's going to read 9x. It's going to read 15y. When I multiply 5 times 3, we get 15. And 3 times negative 1 is negative 3 with a z. And 3 times 12 is 36. So again, all I did was take this top equation and bring it down, multiply it by negative 3, thus giving us this new modified equation, 9x plus 15y minus 3z equals 36. So now we're going to combine those lines, giving us our new equation number 2 without the z's, right? The whole purpose of this was to eliminate the same variable, z, so we could get new equation number 2, 9 plus 4 is 13 with an x. 7 plus 15 is 22 with the y. And 38 plus 36 is 74. Again, this is our new equation number 2. So now we're on to step 3, where we need a new 2x2 system, right? Step 3, new 2x2 system. So I write new equation number 1, right over new equation number 2. So here are my two equations written right on top of each other. And as you can see, it's the same exact equation. So right here, you could already stop and say that your answer is going to be what? Infinitely many solutions. You could conclude that because if it's the same equation and if you were to graph them, they'd end up right on top of each other. They'd have an infinite amount of points in common. Of course, if you wanted to, you could say, I want to multiply this whole bottom equation by a negative 1 if you wanted to continue to eliminate, changing all the signs, which would eliminate, eliminate, eliminate. So you end up with 0 equals 0, which is always true. So you say infinitely many solutions. So number 11, let's eliminate a variable. What do you guys think is easier to eliminate, the r's, the s's, or the t's? T's look pretty decent, right? Again, I look at the 4, the 3, the 5, the 2, the 6, the 2, the 3, the 1, the 4, the 2. I think 1, 4, and 2 are good numbers to work with. So I want to eliminate t's. Of course, you could have decided to do something different. I'm going to eliminate I want to use the first one and the last one. The last one, I'm just going to rewrite it. And the top one, I'm going to modify it by multiplying it by 2, giving us 4 times 2 is 8, and it's with the r. 2 times 6 is 12 with an s. 2 times negative t is negative 2t equals 2 times negative 18 is negative 36. So now we're able to combine the lines, and the t's will eliminate, giving us a new equation that only has 2 variables. So we have a 3r plus 15s equals negative 21. Okay, so that is our new equation number 1. Okay, and let's go back and use the one we have not used, which is the middle one. So I'm going to use this middle one, and I also want t's to cancel. So let me just rewrite the middle one right here, the one I have not used. Let me rewrite it. And we also are going to modify the bottom one by 2. That way it'll eliminate the same t variable. Okay, so instead of rewriting it right below, which you could do that, I'm going to do 2 steps in one to save a little bit of space. So I'm going to take this bottom one and I'm going to multiply it by 2. I'm going to put that in a little cloud just to keep track of what I'm actually doing, and I'm going to rewrite it right below. So if I multiply this bottom equation all by 2, it'll give me a negative 10r, it'll give me a 6s, it'll give me a 4t, positive 4t, and last but not least, it'll give me a 30. And now I'm able to combine the lines. The t's eliminate. Again, it's very important that if we eliminated t's up here, I also eliminate t's down here. So now we have a new equation number 2 that reads negative 7r plus 8s equals 6. Now let's box that in. This is our new equation number 2 right up there. So the whole purpose of writing our new equation number 1 with 2 variables and new equation number 2 with 2 variables is that beginning goal that we had in mind of creating a new 2x2 system instead of a 3x3. So all we're going to do is whoa, that was weird. All we're going to do is put both of these guys together as a 2x2 system. So there it is, right? I just took the new equation number 1, wrote it right there, took new equation number 2, wrote it right there. Here is my new 2x2 system, and I need to solve this 2x2 system. This is step 3 on your flip chart. You just need to solve it and get your 2 answers. So let's do that. What would oh man, this is all messed up. Hold on a sec. So let's make some space here. What would you like to cancel, r's or s's? Which one's a little easier, do you think? I would say r's, right? Because I'd have to change this to a pretty big number and this to a pretty big number. It's easier to do 21 and negative 21. So let's modify both. Multiply by 7, multiply by 3. So multiplying the top one by 7, it'll get us 21r. 7 times 15, that's 70 plus 35, that's 105. Positive 105. 70 times negative 21 is negative 147. Am I right? I hope I'm right. Because if I'm not, everything's going to be all messed up. We're good? Okay, and the last one, or the bottom equation, is going to be modified to negative 21r to positive 24. Oh, I forgot the s on the 105, sorry. 24s, and 3 times 6 is 18. So we've modified it. Let's eliminate those r's. I end up with this disgustingly huge number, 129s. And then on the right side of the equal sign, if we go negative 147 plus 18, what do we get? Thank God. Thank God we get negative 129. It's kind of freaking out right there. So divide by 129, divide by 129. So you'll get s equals negative 1. Ladies and gentlemen, we have one answer of the 2x2 system. Let's find the other of the 2x2 system by plugging it in. So do we want to plug it into the top one or to the bottom one? It doesn't really matter. Bottom. Okay, bottom one it is. So we're going to go minus 7r plus 8s. But instead of s, we might as well write parentheses because we're going to plug in that negative 1 right in there, equals 6. So let's take the s value of negative 1, plug it right in here, negative 1. My new equation is negative 7r minus 8 equals 6. All I need to do is add 8 to both sides. I'll have negative 7r equaling 14. So final step would be to divide by negative 7, divide by negative 7, and I'll get r equals negative 2. Running out of space. So r equals negative 2. R equals negative 2. So we have the r, we have the s, we just need the t. So this is your fourth and final step where you take your solutions of the 2x2 system and plug it into any equation you want on the original to find that missing third value, which happens to be the t value. So which one should we use? The top one, the middle one, or the bottom one? Top one? Okay, whatever you want. And it doesn't really matter. If you pick the bottom, it'll still give you the same answer. So let's go with the top one because you guys picked it. That's 4r, but instead of r, I'm putting parentheses, plus 6s, but instead of s, I'm putting parentheses, minus t, I'm actually writing out the t, equals negative 18. Again, all I'm doing is rewriting this top one, but instead of r and s, I'm putting parentheses. Why is that? Because I have my r and my s right here. That'll go right in there, right? So let's plug in the r, which is negative 2. Let's plug in the s, which is negative 1. And let's do some math here. 4 times negative 2, that's negative 8. 6 times negative 1, that's negative 6. We have a minus t equals negative 18. If we combine like terms, negative 8 and negative 6, that's negative 14 with the minus t. Let me just arrange it like this. Minus t minus 14 equals negative 18. So I have 2 steps to do here. One of them is to get rid of that minus 14 by adding 14. So let me do that. Plus 14, plus 14. And we have negative t equaling negative 4, which means that the t equals positive 4. T equals positive 4. So our ordered triple answer, put parentheses and go alphabetical order, RST. So negative 2, negative 1, positive 4. If you don't put it in order, it's going to be wrong. So that's the answer for number 11. Very long, sorry. But number 18. Yeah, this one's weird, because the first one does not have a z, the second one does not have an x. The only one that actually has 3 variables is that third one. So let's go back to the goal. What's the whole purpose of, or how do we go about solving a 3x3 to convert it to a 2x2? Because we know how to solve 2x2 systems. We solve 2x2s with the elimination method. So it would be nice if I could get a 2x2 system. And what is a 2x2? It's really 2 equations that have the same 2 variables. So notice this first one has 2 variables. That's great. And this one has 2 variables. That's great, but it's not the same variables. So that's a problem right there. Does that make sense? So let's say I wanted 2 variables and I wanted those variables to be x and y. So this one's good to go. If I wanted, for step 3, to make your new 2x2 system, I want to use this guy. This one is a 2 variable equation. It has x's and y's. So I'm going to kind of like remember that this guy is going to be part of my 2x2 when I create it in step 3. So right now what I want to do is combine my other 2 equations to get a variable to cancel. And what variable would I like to cancel? Since there is no z on this one, I would like to cancel z's. Are you with me? So I would like to cancel z's, and how would I do that? Well, using these 2, I'd have to modify this bottom one by 4. So multiply it by 4. I want to have a new equation. 4 times x is 4x. 4 times 6 is 24 with the y. 4 times z is 4z. And 4 times 20 is 80. Now, the middle one, I'm just going to rewrite it over here right on top of it. However, when I rewrite it, notice there is no x, so I can't really write anything on top of x, but I will write the 3y right on top of the 24y. So let's put 3y right here, and then the minus 4z right on top of the other 4z, and the 25 right on top of the 80. Are you with me? Okay. So again, I decided to not mess with this top one because it already has only 2 variables, x and y. So I started thinking, well, it'd be nice if I could change these guys, do some manipulation and combinations so I could get the z also to cancel. That way when I get my new equation over here, it'll also be an equation of x's and y's. Okay, so let's do that. Let's combine the lines. And when we combine the lines, the z's eliminate. And obviously there's nothing to combine with the 4x, so 0 plus 4x is exactly that, 4x. The 24 plus 3 is 27, and we are talking about y's. equal sign comes down, and 25 plus 80 is 105. So ladies and gentlemen, this is what we call our new equation number 1, if we want to call it that. Or you could also call it new equation number 2, because the bottom line is you already have this other equation that has x and y's. You already have this one that you just changed to cancel out z's to have x and y's. So this is your new 2x2 system. You're going to use this one and this one. Now, if you're thinking, well, no, I want to follow the steps. Okay, well, what did we do? We use this one, we use this one, we canceled out z's. Now you have to go back and use the one you haven't used. So we need to use the top one, the one we haven't used yet. And that step 2 says use the one you haven't used and get the same variable to cancel. So we purposely canceled z's. There's no z, so we're already done with that step. It's like given to you. So x plus 2y equals 12 is technically our new equation number 2. Even though we didn't do anything to it, it's x plus 2y equals 12. So this one was new equation number 1, and this is new equation number 2. So now we could actually create our 2x2 system. So let's write our 2x2 system. All we're going to do is put the top one on top and the bottom one right next to it. So there it is. All I did was rewrite it. We're going to now look at this 2x2 system, and we're going to figure out a way to cancel out or to solve it, right? So what do we want to eliminate, x's or y's? X's look a lot easier because we have a 4 and a 1 as opposed to a 2 and a 27. So let's eliminate x's by doing what? Multiplying by negative 4. That'll give us a new equation on the bottom, new modified equation, negative 4x minus 8y equals negative 48. And on top, we're just going to rewrite it right above. So that's going to be right there. And if you're watching this for the first time on video, hit pause so you could catch up right there. But anyway, we're going to combine these lines. The 4's really do eliminate. 27, take away 8. What is that, 19? 19y. Bring down 105, take away 48. I do not know what that is. That's 50, 57? 57? And I hope somebody checks that on calculator, because if I make a mistake here, everything's done. Thank you. Thank you for verifying. Okay, so now let's get rid of that 19. And this looks ugly, but I believe it works out nice, right? 57 divided by 19 is 3. So we have one nice answer. Let's find the other nice answer in our 2x2 system. So going back to the 2x2, we took... we're going to take the y equals 3 and plug it in either to the top one or to the bottom. Obviously, the bottom looks easier, so let's rewrite the bottom one. The bottom one reads x plus 2y equals 12, and we are plugging in a 3 right there. So you really have x plus 6 equals 12, which means that if you subtract 6 on both sides, you'll get your answer x equals regular 6. So x is 6, y is 3. We still need z. So we're going to go back to the original and plug in our x value and our y value to find the z value. And of course, I would use this bottom one that has the x and the y and the z. So let's plug in x right here, the 6 right here. Let's plug in 3 right here and keep everything else the same. Let me rewrite the whole thing. X plus 6y, parenthesis, plus 6 times parenthesis, plus z equals 20. Okay, so let's put a 6 right here, plus a 3, or 6 times 3 right there, plus z equals 20. Let's do some math. 6 plus 18, 6 plus 18 is 24. 24 plus z equals 20. Get rid of the 24 by subtracting 24, and you will get z equals negative 4. So there's your answer. Let's write it as an ordered triple. X is 6, y is 3, z is negative 4. So there's the answer to this one. Okay, so let me reiterate the thought process here. Step 1 is to pick 2 equations and get something to cancel. Now, before doing that, I recognized that there was already one equation that only had the x and the y. The z was already canceled. It's not even there. So knowing this, I could have used this one, but this is a nicer one. It's easier numbers. So I decided to not mess with this one and modify these 2 for step 1 to get the z variable to cancel, so I could end up with x's and y's just like this top one is, right? So step 1 was rewriting this one, manipulating this one. That way z's cancel, and here's my new equation number 1. New equation number 2 comes from step 2, which is going back and using the equation you have not used. All I did was rewrite it, and you want the same variable to cancel, which is z's, and it didn't even have a z to start with, so it's kind of like if that step was done for you. And then you take your new equation 1, your new equation 2, and create a new 2x2 system. Here it is, the top equation, the bottom equation. Solve it the way you always would with linear combinations. Get your two answers, plug in the x and the y, back into the x and the y of the original to be able to solve for z, and we got z equals -4. That's the answer. What do you guys think? This is number 19, the last question on our homework. And again, your goal is to get a 2x2 system going so you could solve the 2x2 system. So you want to pick two equations and you want to eliminate a certain variable. So let's eliminate r's. Now I might as well start modifying. If I want the above r to cancel out with this 3r, what would I have to do? What would I have to do?
Negative times negative.
Yeah, multiply the top one by -3. Very important that you actually show the parentheses, that you show the number that you're multiplying by, and also draw some arrows. That way you don't make mistakes. So let's modify this correctly. -3 times r is -3r. -3 times -3s is positive 9s. -3 times positive t, that's -3t. And we still have -3 times 4, which is -12. That is our new modified top equation. Now the bottom or the middle equation, all we're going to do is simply rewrite it right below it. There it is, 3r minus 6t plus 9t equals 5. I just copied it over again. And now I'm going to combine the lines to eliminate the variable r. And we're only eliminating the variable r because you guys told me to. You could have eliminated s's, you could have eliminated t's, but r's look pretty easy, so let's do this. 9 take away 6 is 3 with an s. -3 plus 9, that's positive 6 with a t. And then -12 plus 5 is -7. Ladies and gentlemen, this is a new equation that only has 2 letters. It only has 2 variables. This is what we call new equation number 1. Now let's go back. Step 2 says go back and use the equation you have not used. Which one have I not used? The third one, la tercera, that's right. So we're going to take this one and we're going to just rewrite it. I mean, you could leave it there, but I'm going to rewrite it so it'll be crystal clear for everybody. Let's rewrite it. There it is. I rewrote it. And if you look at your instructions, your steps, step 2 is to use the equation you have not used and then get the same variable to cancel. So which variable did we cancel up here? R's. So I need this 4 to disappear. I don't want R's. So I just rewrote it here. Which one am I going to use to cancel out that 4? The top one that has an R or the middle one that has a 3R? Top one, right? So I'm going to take the top one. If you have different colors, this might help you. I'm going to circle the top one, and I want to draw an arrow this way. But as I'm actually bringing it down, I might as well multiply it by -4. So I want to put dot -4 right there. Actually, let me rewrite it better. I'm sorry. Times -4. So if I put a times -4 in a cloud as I'm drawing my arrows down here, I'll know how to retrack my steps if I need to. So if I think, okay, r times -4, that's going to give me a -4r. If I think -3 times -4, it's going to be a positive 12s. If I think t times -4, it's going to be a -4t. And last but not least, 4 times -4 is going to be a -16 on the right side of the equal sign. -16. Everybody with me? Okay, so now we're able to combine the lines. The r's eliminate. 12 take away 9, that is 3. And of course, we're talking about s's. 10 take away 4 is positive 6, and we're talking about t's. And 9 take away 16 is -7. So ladies and gentlemen, we have just found new equation number 2. Wait a second. When we move on to step 3, which is to create our new 2x2 system. Remember, this is step 1 up here. We found our new equation number 1. This was step 2 down here. We found new equation number 2. Here's step 3. Create your new 2 by 2. So let me write my new 2 by 2. It's simply writing the new equation 1 together with new equation 2. Check it out. Here's my new system right here that I need to solve. I need to solve, find out what S is, find out what T is, and then I could plug in both S and T into the original to find that missing value R. However, as you guys already noticed, it's the same exact line. So if we're talking about the same exact line, you could think about the visual. It's going to be the same. Think about the amount of points in common. There's an infinite amount of points in common. So what's your answer? IMS. Now let's say you wanted to just keep going. Let's say I want to cancel out S's. All right, well you'd have to multiply everything by -1 on the bottom, which would change that to a negative, change that to a negative, change this to a positive. And when you combine lines, everything eliminates. And if 0 equals 0, that's always true. That's where you say infinitely many solutions. And you can't abbreviate IMS, but we need to understand what it truly means, that there's an infinite amount of answers to this 3 by 3 system. So this was one of those special cases. I'm done.